Now we come to some application of the resistive circuit. This is the Wheatstone bridge circuit. The Wheatstone bridge is the resistive circuit that frequency used in measuring device. So if we connect the resistance in this form, we have R1, R2, R3, and Rx. Rx is maybe unknown, usually unknown, or any value of Rx. So Rx may be the sensor, some type of sensor. For example, if we are here with some monitor or control system, and we have some sensor, 2Y sensor, 2 or 3Y sensor. This sensor could be some resistance that vary according to temperature or pressure. Or any measuring value. So if the temperature change, the resistance is changed. If the pressure is changed, the resistance is changed. Okay, then we connect this value, come to some circuit. So if this resistance is changed, the voltage is changed, okay? Here, right? It will affect the voltage. The voltage could be maybe some monitoring value, right? We can see how much the temperature, right? By this method, okay? By this sensing method, okay? This type of sensor. You will learn, I think you will learn measuring device, right? In some course, right? In your curriculum, right? In your program. Or sometimes the pressure is changed, the voltage will be changed, so we can convert this voltage, right? For example, we can convert this voltage maybe 0 to 10 volt, maybe mean 10 to 50 degree Celsius, for example, right? To show, or to use this for control something. So when we use sensor, often we use this type of circuit. Right? We use this type of circuit, and we call it Wheatstone circuit. So in this case, R1, R2, R3 is known value. We specify, we design this circuit for Rx. This is unknown resistance. Here we may draw the circuit in this form, right? This is the same circuit, right? And we call this node A and B, VA and VB, right? This is VA and VB. Right? Sorry, the chain voltage is not VS, but VAB. Sorry, VAB is chain. This is source voltage. This is the source voltage, and when the value of resistance is changed, we measure, right? We measure VA and B. VA and B here, right? It's changed, right? If Rx changed, V in between AB will be changed. Here is a circuit that we can use for analyze, right? I1, R1, R3, R2 is a known value, and this is something unknown. Okay. So to find the voltage VAB is VAB minus VBB, right? VAB is VA minus VB, and we use node D as reference. So this will be V in between A to D minus V between B to D. Like this, right? So if R1, R2, R3 is 1 k ohm, this is 1 k ohm, 1 k ohm, 1 k ohm, and Vs is 12 volt, right? VAB is 12 millivolt. We can compute for Rx. So VAB can be a represent value of Rx. So let's see, VAB here, VBB is here. If we use voltage divider, VAD will be VAD is Vs into R2 divided by R1 plus R2. This is by voltage divider, right? Then we just talk about voltage divider. VBB, similarly, VBB would be Vs Rx divided by R3 plus Rx here. Therefore, VAB is VAD minus VBB, right? We just talked about this formula. Substitute, we get Vs into R2 by R1 plus R2 minus Rx divided by R1 plus Rx, right? Substitute, and is 1K, 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 1K. So we get this. If we measure if we have some meter here and it shows 0.12 millivolt, we know that we supply the voltage at 12 volt, and we know that our circuit is 1K, 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 right? If we measure VBB and E, is 0.12 millivolt, we can compute Rx from this equation, right? We can solve for Rx. We can solve for Rx, and we get that Rx is 996 ohms, right? Okay. Practically, the circuit is here, but Rx may be take the long while to the measuring device here. Our circuit is here, and we take the wire to the sensor, right? So maybe a long distance, right? You take the value of it's 996. So we can compute Rx by, if we know VAB, if Rx change, VAB will change, we can recalculate for Rx. And this may be represent like some sensor. Some sensor may be resistive type sensor. That is the temperature is changed. resistance is changed, right? Or the ratio is changed, sensor is changed, like that. Okay, check your understanding. Right? If VA and VB is 0, if VA and VB is 0, this is I will explain. You don't need to go back to check, okay? There is some important point here. If VAB is the same potential, right? VAB equal to 0. This means VA and VB is the same value, right? So with this voltage divider, VA is R2 divided by R1 plus R2, and VB is Rx divided by R3 plus Rx. This means that the ratio between R1 and R2 equal to R3 and Rx. Therefore, R1 and R2 will be equal to R3 and Rx. The ratio between this value. For example, if R1 is 4 and R2 is 8, if R3 is 2 and Rx is 4, this means the voltage across VA and across VB will be same, right? Okay, this ratio will be true for A and B equal, right? We call this is balance bridge circuit. It's balance. Okay, it will be balance like this, or maybe 1 and 2, or any value that make this equation, right? True, right? Make this equation any value, R1 by R2, any value, but the ratio will be the same. Right? This is the balance bridge circuit in this case. Just for this condition, right? Just for this condition. On the other hand, if we adjust some R1, R2, R3, Rx. So Rx is unknown. And we know about R1, R2, and we make R3 adjustable. Adjustable resistance. And we measure this voltage. So if I don't know about Rx, or what is Rx, I don't know, and I try to adjust R3 until the voltage is 0. Okay, if I adjust Rx until the voltage is 0, then after that I know Rx. Okay, I can know Rx because it will be complied with this condition, right? Okay, when I know R3, I will know Rx, right? This will comply with the condition. So we use this type of method a lot, right? With Stonebridge in measuring circuit. Okay, this is an example of stand gauge. Stand gauge is the measuring device that will be changing its resistance in according to the strain of places to it here, stand gauge. Because if it's bent, if we install this type of it into some structure, if this structure is bent, we install R2 and R3 here. R2 and R3 at the lower, at the bottom surface. And we install R1 and R4 in the above surface. When the force push here, R2 and R3 will be placed, right? Because we have the condition A and R is rho L by A and L. When you place this, the length is reduced and the cross section and length increase. Okay, so this type of material when you force it, the resistance is reduced, right? So the resistance R2 and R3 will be increased, right? Increased by force. But R1 and R4 will be decreases by force, right? In different direction, right? These two increase, these two decrease like this. So we can measure the force, we can transform the signal into the force placed into this type of material, right? So the resistance change when the force applied to this type of equipment here, like this. Or we can use it with stone brick, right? With stone brick. Usually out and get this fold together. And usually in industrial system, they already install together into one type. Okay. For example, in the elevator, under the floor of elevator, to measure the weight, right? To measure the weight and transform it into the signal, right? So if we are the last person who get into the elevator, right? The elevator can alarm because of our weight, right? Very enough, right? So many people get to the elevator. This type of equipment, right? We use it industrial, many industrial applications. Actually, out, this is the signal, right? To alarm or to show what is the way to apply to this material. Here. This is the force applied to the resistance. This we call the G factor, right? GF is the chain of resistance due to the chain of the range. Okay. Chain of resistance due to the chain of the range. Okay. I think this part I will not go to detail of calculation, but just you get some idea. Okay, But if you're interested in how to calculate, you can go. It's not so difficult. Okay, this is for check your understanding. Okay, before end of this slide, we talk about the practical voltage and current. I think I already talked about it. Okay, the practical voltage. Okay. You have resistance, right? And the practical current source also. Okay. You have the internal resistance. When you solve practical voltage, you need to include internal resistance in your formula. Right? Similarly for the practical current source, right? Yes. Here, the current V, current is T. And we can use ohmmeter to measure the resistance as well. So in the laboratory we will have ohmmeter to measure the resistance. Okay. And ammeter we will use for current measurement. Okay. So for example, if you would like to know about how much the current flow here, we can use the ammeter. And in solving the circuit, ammeter will be represented as short circuit, right? There's approximately no resistance at all when we solve it. So ammeter is represented as zero internal resistance, right? Ideal ammeter, for the ideal ammeter. But practically, when you put the ammeter to the circuit, there is some small resistance here, right? Some small resistance. It affects your circuit, right? But ideally, we assume that the resistance is very small for ammeter. And for voltmeter, okay, usually we measure the voltage between 2 points, right? The voltage will come into the circuit by parallel, right? Shunt circuit. And we also assume that the impedance of the voltage is very high. When we solve the circuit with voltmeter, we assume there is no current flow here. So this is the open circuit, right? Similar to open circuit, is very high resistance, infinite internal resistance, very high. And assume this is an open circuit. But in fact, there will be some current leak here, right? Some very small current leak. Okay. And when we measure the power, we can use wattmeter, right? V and I. What we can use voltmeter and ammeter and multiply together, or we can use wattmeter like this. The wattmeter will measure both current and voltage and calculate for us to power. Okay, this is for your practice, right? For your homework. This is your first homework, right? Almost midterm, right? So I think you can do it very well. Right. What should be the deadline of this homework? After the midterm. After midterm. If you do it after midterm, you will have some trouble doing midterm exam, right? Maybe this homework, if we talk about this homework, you can do it all, but maybe I will select only some question, right? For you to submit next week. Okay, next week.